Good morning. I've been given the opportunity and the privilege and the honor of introducing the famous Mr. Peer. He'll be coming here in just a moment. But wait a minute. Oh no. Oh no. I feel like something is coming up in my throat. I'm getting hot. I'm getting hotter. What's going on? Oh no. Oh no, my head is going to explode. Ah, Mr. Peer, come quick. Oh, you sissy. Okay, I'm coming to rescue you. You're okay. It doesn't matter. What a sissy. Just because his head's turning green. Okay, let's look at the assignment. We are checking page 435 and 436. But yes, once again, just like yesterday, before we check this, we are going to pause the video. So whoever's running the video, please hit pause for a moment while we collect. Page 435 and 436. Be sure your name is on the paper. By this time, they should all have been passed forward and collected in a pile and placed on my desk. Thank you. So, checking page 435 first. Starts off pretty easy. This is the kind of thing you should expect to see on the test. Something relatively simple like this. Now, the book writers essay, they threw something different at you here. They actually asked you in the instructions for the median. We don't know how to do that. Oh, yes, you do. That's old stuff. We did medians of trapezoids a long time ago. What chapter was that? I have no idea. But we have seen medians of trapezoids. Back on the chapter about quadrilaterals. So let's start by finding the median. You may remember, then again, maybe you don't. Hey, you know something? If you looked at these instructions and you said to yourself, I don't know how to find the median, so I'm skipping that. Don't be lazy. If you're not sure how to find a median, then look it up in the index in the back of the book and go back to find out how to find the median. Don't be lazy. Be a student. Yeah, bud. Well, how do you find a median? The median is just the average of the two bases. How do you find the average of a 7 and a 13? Add them and take half. So we will, to find the median, we will add 13 plus 7 and take half. That's how you find a median of a trapezoid. So the median, this little dotted line here you can barely see, the median must be half of 20. That's going to be half of 20. That's going to be 10. So the median is 10. We've answered the first question. The median is 10. Congratulations. But now what about the area? There's a reason why they asked you to find the median, because there's something cool here that I don't believe we've mentioned before. Although, no, that would be new information here. Doesn't this remind you of the formula for the area of a trapezoid? Because the area of a trapezoid, which is what we're looking for here now, is 1/2 times the height, 1/2 times the height times B1 plus B2. Well, look at this. We already have 1/2 times B1 plus B2. It turned out to be 10. We already have 1/2 times B1 plus B2. All we have to do now is multiply by the height. It's a shortcut. If you've got to find the area and the median, just find the median first and then multiply by the height. The height is 5, so the area of this whole thing has to be 50. Now, if you don't want to go to that trouble, I don't understand what you're talking about. Okay, then just use the formula 1/2 times height times sum of the bases. That's 1/2 times the height, which is 5, times the sum of the bases, which is 13 plus 7. And see, let me highlight it. This part here 1/2 times 13 plus 7. Doesn't that look kind of familiar? That's the median times 5 times the height. So any way you look at it, you're going to have half of 20 is 10. 10 times 5 is 50. The area is 50. That wasn't too tough. Even if you didn't see the little trick of doing the median first and multiplying the median by the height, just using the formula, hey, you've got it. Add the bases, multiply by the height, take half, bang, done. On the test, it'll be that easy. You're kidding me. Nope, it'll be that easy. Let's look at number 2. Number 2, shortcut formula. We'll get to that in a minute. Let's go ahead and do the median first again. Why not? The median is 1/2 times the sum of the bases, as we learned back in an old chapter. It might have been chapter 4 or something. It was a long time ago. So for the median, it'll be half of 13 plus 5. Half of 18. Half of 18, the median must be 9. Median is 9. Now for the area is 1/2 times the height, which is, oh, interesting. They didn't put a height in here for you, but they didn't need to, because this side of the trapezoid is perpendicular to the base, so that is the height. Oh, I see now. Good. So it's 1/2 times the height times the sum of the bases, 13 plus 5. 13 plus 5. Half of 18, that's 9. That's 9 times 6 being 54. Area is 54. Or we could have done half of 6 is 3, and 3 times 18 is 54. Or we could have done 6 times 18, and take half of that answer, and you'll get 54. Doesn't matter how you do it. Just, I'm going to say it again. Don't take half twice. Taking half twice is the same thing as taking a fourth, and we're not supposed to take a fourth. We're only supposed to take a half. Just do it once. All right, is there a shortcut formula for the area of this thing? Well, yeah. We could say the shortcut formula is find the median, let's call it m, and multiply by the height. There's a shortcut formula. Median times height. Median times height. 54. You may use that shortcut formula if you want to, but if your head is crammed full of so many formulas that you don't want any more formulas, you don't need that. But it's a nice shortcut that you can make use of. Number 3. Now this time, it might bother you a little bit. There may be some folks who are tempted to think that 12 and 13 are the bases. There's a problem with that, because in a trapezoid, by definition, the bases are the parallel sides. The bases this time are the 14 and the 9. If you want to turn this whole thing sideways to make it more obvious to you, feel free. Can I turn this sideways gracefully? No, I can't. Well, if you wanted to turn it sideways, turn it sideways. Flip your book around if you want to. So the area is, let's just pretend we don't know any shortcuts, okay? Area is 1/2 times the height times the sum of the bases, b1 plus b2. Well, the height, because these are the bases, that makes what the height? Remember, height has to be perpendicular to the bases. So, what is the height? My watch is buzzing at me here. If the height has to be perpendicular to the bases, that means this must be the height. So, 1/2 times 12 times the sum of the bases, which are 14 and 9, that's 23. And again, wisdom would say, don't take half of 23. Take half of 12 instead. It's your choice. Do it the easy way. That's 6. 6 times 23 is going to be what? 138, right? 138, I do believe. If I'm doing that correctly in my head, yep, 138. So the area is 138. 6 times 23 is 138. And what about the median? Median's no big deal, right? You just add the bases and take half. 14 plus 9 is 23. It's half of 23. Well, what's half of 23? Oh, come on, you can do that. Half of 23. What's half of 22? 11. So if half of 22 is 11, then half of 23 must be 11 and a half. Yep, median is 11 and a half. And I don't care whether you write 11.5 or 11 and 1/2, or you can even write 23 halves. They're all the same thing. They're all the same. Now we go to the written exercises. Okay, let's try to pick up the speed here. For the written exercises, area is 1/2 times the height times B1 plus B2. Oh, that plus sign looks wonky. It's that glitch in the board. Sorry about that. So we have 1/2 times the height. The height is 6.1. The bases are added to 6.8 plus 3.2 is going to be, exactly 10. How about that? That's easy. So now we have 6.1 times 10 is 61. Half of 61 is 30 and a half. The area is 30 and a half. 30.5. Checking my work, make sure I'm not doing anything silly here. I hate to move on and having made a mistake. This is that one where we have, yes. They don't give you a diagram, but that's okay. You don't need one. I gave you one here. And yep, we get 30 and a half. What about the median? Well, the median is the average of the two bases. Add the bases, take half. Oh, well, that's easy. This adds up to 10. Half of 10 is 5. That's got to be 5. Hey, is it believable that 5 is halfway between 3.2 and 6.8? Yeah, that makes sense. Yep, it does make sense. So the median is 5. Ta-da, done. Number 4. We once again have a trapezoid, we're told. But this time, did we finish? We did the area, we did the median. Yeah, we finished. Okay. Number 4. This time they give you the area. Now that's different. They give you, here's our formula. They gave you the area. Fill it in right there. They also gave you the two bases. Fill them in there and there for B1 and B2. Now we just solve for what we don't know. The only thing we don't know is H. Well, 45 plus 15 is 60. Let's take half of 60. We can do that. Take half of 60, that's 30. Now divide by 30, and guess what H is? H has to be 10. 300 divided by 30 is 10. So the height is 10. What else do we want to know? We want to know the median. The median is easy. You don't even barely have to do any work. You just add the bases and take half. That's going to be 60, and half of 60 is 30, and we're done. We move on to number 6. How am I doing time-wise? Let's see. I have to stop a certain time here. Okay, I think we're doing all right. Okay, number 6. Again, area, 1/2 times height times sum of the bases. By the way, on the test, I do not give you that formula. You have to know the formula for the area of a trapezoid before you walk into the test. When's the test? I don't know yet. I haven't figured that out. But when we do have the test, you have to know the formulas. I will not give them to you. And if you know the formula, then everything else becomes easy. So this time, we're told the area is 12. Thank you very much. Right there, we're given the area is 12. And we have one of the bases, and we have the height. What we don't know this time is the other base, B2. So what do we do? Well, let's just dive in. Now let's see, we have, this is a little bit painful. Let's do this a piece at a time. let's get rid of this nasty fraction. How can you get rid of multiplication by 1/2? How about if we multiply both sides of the equation by 2? Because 2 times 1/2 cancels. And here we now have 24 equals 3 times 3 plus b2. Now we need to get rid of that 3. How do we get rid of multiplication by 3? Ah, yes, we divide by 3 on both sides. What's that give me? Well, these 3's cancel, of course. That's why we did it. 24 divided by 3 is 8. And now all we have to do, don't need this parentheses anymore, now all we have to do is subtract 3, and we find out that b2 is 5. Congratulations. These book writers like that number 5. We see it a lot. Would I ask you one quite that complicated? That's not complicated. But would I give you one like that on the test? Probably not. Oh, good. I was getting worried. Oh, come on. Now, what about the median? Well, now that we know that b2 is 5, now that we know that b2 is indeed 5, finding the median is easy. 5 plus 3 is 8. Half of 8 is 4. Median is 4. And we move on. Number 8. Yet another one. This one's kind of weird because it involves a variable. No, not a variable. Yeah, a variable. You know something? We don't care what k is. K is of no concern to us. Really, we don't have to find k. We can't find k. K could be anything. So, we take our formula. We plug in what we know. We're told the area is 45k squared. There it is. Area, 45k squared. We're told one of the bases is 3k. There it is. We're told the height is 5k. There it is. And now we just do something very similar to what we did a little bit ago. First, let's get rid of this 5k by dividing both sides by 5k. Divide by 5k. If we divide both sides by 5k, these 5k's cancel out. That's why we did it. Wow, that looks a lot like our Algebra 1 that we did last year. It is. The 90k squared divided by 5k, the 90 divided by 5 is 18, and k squared divided by k is just k. And no, I would not give you anything like this on the test, guaranteed. And then, we're very close to being done. Now, to get that b1 by itself, because we're looking for b1, we just subtract 3k. Subtract 3k, subtract 3k, b1 turns out to be 15k, and we're done. But what's k? K could be anything. We don't know, we don't care. That's not what we're looking for. We're looking for b1, and it's 15k. Done. So if b is 15k, then what's the median? Add the 2. 15k plus 3k is 18k, and guess what half of 18k is? Is it 9k? 9k. Median is 9k. That was terrible. Oh, it wasn't that bad. Come on. Get over it. Number 10. Okay, tell you what. To save some time here, because I am running out of time, to save some time, I'm just going to throw the answers to 10. How far did I send you? It was up to number 12. Oh, we were supposed to stop at number 8. We're done. Okay, we're done. That's it. It's over. So now we can move on to the next section. Of course, I'm going to ask the board to do something, and you know what happens. Something's wrong with this board. Every time I ask it to do something, it takes 30 full seconds. I want to switch to the other file, and now we wait. And we wait, and we wait, and we wait. And this is Tuesday. I hope you enjoyed the eclipse. I hope you didn't get a blind spot on your retina from staring at it. And we wait for the board. And we wait, and we wait. What else can I do to entertain you? I can dance. No, never mind. And we wait, and we wait, and we wait. Make sure you know all these formulas for the test. All right, here we go. We're now looking at, I'm on page 440, and we're looking at the areas of regular polygons. Remember what a regular polygon is. A regular polygon, like this pentagon, has all of its sides congruent and all of its angles congruent. That's what makes it regular. I sometimes refer to regular polygons as pretty polygons. Here's a regular heptagon. 7 sides. 1, 2, 3, 4, 5, 6, 7. A regular octagon. 8 sides. A regular hexagon. 6 sides. A regular decagon. 10 sides. These are all regular polygons. By the way, as you're going to find out, hexagons are special. Hexagons are really fun to work with. So expect to see some hexagons on the test. Hexagons are cool. You'll see why later on. And no, it's not because they are the terrain pieces for the game Settlers of Catan. That happens to be true. But no, hexagons are special for other mathematical reasons. We'll see that later. All right. There's something special else special about all of these. Any regular polygon can have a circle circumscribed around it with no problem. You can circumscribe a circle around all of these without any problem. You can always circumscribe a circle around a regular polygon. Always. Now you can't do that with any old polygon. Suppose we had a pentagon shaped like this. 1, 2, 3, 4, 5. You can't circumscribe a circle around that. You can get a polygon, a circle to go through 3 points, but it's not going to go through all of them. It can't happen. In order to circumscribe a circle around one of these regular polygons, it has to be a regular polygon. Okay, I just said it. Now, also notice, the more sides the polygon has, the closer the polygon gets to looking like a circle. Interesting. Now, here I've done it for you. Forgotten that I had this in my file. There's a circle circumscribed around a pentagon, and a circle circumscribed around a heptagon, 7 sides, a circle circumscribed around an octagon, and a hexagon, and a decagon. All of these can have circles circumscribed around them because they're regular polygons. Now, definitions. When you have a regular polygon, there are some special parts. Because we can indeed circumscribe a circle around this regular polygon, that circle has a center. So henceforth, forevermore, from now on, we will refer to the center of that circle, that circumscribed circle, as being the center of the regular polygon. Yes, regular polygons have centers just like circles do. So the center of this regular polygon is point O. And yes, a regular polygon also has a radius. A radius is the distance from the center to one of the vertices. Or in other words, it's the radius of the circumscribed circle. So we have 2 radii. One radius would be segment OB. Notice the bar on top, it's a segment. And another radius would be OA. OA. Hey, what's true about those 2 radii? Yeah, you got it. All radii of a circle are always congruent. Therefore, all radii of a regular polygon are always congruent. Now, if we take 2 consecutive vertices, consecutive means one right after the other, not skipping from here down to here, but 2 consecutive vertices, and connect them like this, we get what is known as a central angle. There's one central angle we can name here. A central angle has to go from vertex to center to the next vertex. So the only central angle we can name here is angle. Notice the angle symbol. You've got to have your symbols in there. Angle AOB. A-O-B. Now here's a new word. It sounds like you've developed a lisp. Apothem. Apothem. The apothem, weird word. The apothem is a segment from the center perpendicular to a side. Not to the vertex, but perpendicular to a side. That is the apothem. So the apothem in this case is segment OC. So OB is a radius, OA is a radius, but OC is an apothem. There are other apothems I could draw. I could draw this one perpendicular to that side. I could draw this one perpendicular to that side. There's another one perpendicular. Apothems have to be perpendicular to a side. We have 6 apothems in this hexagon. We also have 6 radii in this hexagon. All right, those are the definitions. Now, let's play with this. Consider this hexagon. And I've marked for you right here. Oh, yellow's not going to show up, is it? Let's use white. I've marked for you right here the apothem. It's perpendicular to a side. That is the apothem of this regular hexagon. Now watch what I am going to do. Because we're working toward something here. We're working toward getting a formula for the area of any regular polygon, like this one. What time is it? Gotta watch the clock. I've got 9 minutes left. Okay. So watch this. We're going to take this thing and we're going to open it up. Oh, look at that. We're not changing the area. We're just opening it up like segments of an orange. And there it's opened. Let's keep going because I moved this up some here. Let's move it up, move it up, move it up. All right, now. What is the distance across here? Isn't the distance across there? Where did it come from? Well, put it back together. The distance came from the, oops, went too far. It came from the, what do you call that? That is the perimeter of the polygon. So we take that perimeter and we simply open it up. So we have opened up the perimeter. Here it goes again. So the perimeter is now laying flat. And we have a bunch of equilateral triangles now. So the length of this thing is 1, 2, 3, 4. Oh, I'm sorry, wrong. I'm thinking wrong here. But these 6 pieces all add up to the perimeter. All right. Now, what's the area of this one triangle? Area of a triangle, 1/2 base times height. Well, the height is the apothem. I'm trying to remember what this was here for. What is that for? That comes later. That comes later. So the area of this triangle is 1/2 times its base times the height. 1/2 base times height. But wait a minute, the height has a special name now. The height is what? The height is the apothem. So this one triangle has an area of 1/2 times the base times the apothem. Hey, we like alphabetical things. Let's flip that around and write 1/2 apothem times base instead, okay? Okay. Now here's where it gets interesting. How many of these triangles do we have? We clearly have 6 of them because it was a hexagon. So, what is 6 times this base? One of them plus another one, plus another one, plus another one, plus another one, plus another one. 6 times the base equals what? 6 times the base equals the perimeter. So instead of writing 6 times the base, I'm going to change that to the perimeter. So, if you followed that argument, great. If you didn't follow it, I don't have time to elaborate anymore on it. Let's simply say this, that the area of any regular polygon ends up being 1/2 times the apothem times the perimeter. Oh, here we have further explanation. The height of this triangle is the apothem, so I can change that h into apothem. And then I have 6 of them, so I multiply by 6. But 6 times the base has a better name. 6 times the base is known as the perimeter. And if we rearrange that a little bit, we get 1/2 times the apothem times the perimeter. That is the formula for the area of any regular polygon. 1/2 times apothem times perimeter. Now, let's see what this ends up looking like. In this particular case, well, okay, we have the center, again, is point O. The radius, we've got 2 of them, OB or OA, either one. I'll just say OA, save time. We've got a central angle of angle AOB, angle AOB. We have an apothem of OC. Apothem is OC, and the area is 1/2 times the apothem times the perimeter. Now, we don't know what these things are yet, so we're done. An example. Here's a regular hexagon. We're given the apothem is 9. We need to know the area. But wait a moment, we have a problem. What is the perimeter? Okay, here's how we get the perimeter. This is what's really special about hexagons. Regular hexagons are super special. With a regular hexagon, if you take a radius and another radius and a side, you will always get an equilateral triangle. Cool! Well, if that's an equilateral triangle, and that's 9, do you remember how to go from long leg to short leg of a 30-60 triangle? From long leg to short leg, you divide by square root of 3. But how? Glad you asked. If there's a square root of 3 to drop, then we drop it. But there isn't. Then we take a third and stick a square root of 3 next to it. This piece here has to be 3 square root of 3. Just like this is 3 square root of 3 also. So that means the entire side is 6 square root of 3. Oh, 6 square root of 3. 6 square root of 3. It's regular, they're all the same. 6 square root of 3. 6 square root of 3. 6 square root of 3. Add them up, what do we have? We have 36 square root of 3. The perimeter is 36 square root of 3. That's the answer to the question. So now, let's use the formula. We have a perimeter of 36 square root of 3. So the area is going to be 1/2 times apothem. Oh, we know the apothem. Ha-ha! Yeah, we were given the apothem. It's 9 times the perimeter, which was 36 square root of 3. So I think what I would do is take half of 36. That's going to be 18 square root of 3. And then we have 9 times 18 square root of 3. And what in the world is 9 times 18? That's going to be 90 plus 72. That's going to be 162, right? I believe it's 162 square root of 3, and we're done. 90 plus another 72. Yep, 162 square root of 3. Hey, there is another way. The other way is just figure out the area of one triangle. And remember, we actually have 1, 2, 3, 4, 5, 6 of them. So the other way, instead of doing 1/2 apothem times perimeter, you can just find the area of one triangle and multiply by the number of triangles. That works too. It's your choice. But why not use 1/2 apothem times perimeter? Yes, sometimes it's a little bit tricky to find out what the perimeter is if you're given the apothem, but it's not that bad. Not that bad. Here's another example. This example is actually easier, and do I have time? Ooh, just barely. Let's squeeze this guy in. I've given a regular hexagon. Yeah, we love hexagons. A regular hexagon, the radius is 4, and I'm told, oh, I need to find out what S is. I don't have anything else. How are we going to do that? Well, remember, this is so cool. I love hexagons. When you put in 2 consecutive radii of a hexagon, you always get an equilateral triangle. Which means if this is 4, then this has to be 4 also. Nice. Then what in the world is the apothem? Well, if that's 4, this piece must be 2. And so we use the Pythagorean theorem to figure out what this guy is. A squared plus B squared equals C squared. We can get the apothem. I don't have time to get it for you right now. The perimeter is going to be 4 plus 4 plus 4 plus 4 plus 4 plus 4 times 6, because there are 6 sides. That's going to be 24. And the area is therefore 1/2 times apothem, whatever we're going to get. I just don't have, I'm not going to do it right now because I'm out of time. Question mark. Well, make that look like a question mark. Times the perimeter is 24, so the area will be 1/2 of 24. It'll be 12 times whatever the apothem turned out to be, 12a, whatever this turns out to be from the Pythagorean theorem, and you're done. Not bad stuff, not bad. Squares are kind of special. Here's our apothem, here's our radius. Hey, you know how to do this. This makes, in a square, squares are also nice. Squares give you a 45-45 triangle. How cool. Well, a 45-45, hopefully from chapter 8, you remember to get from the hypotenuse to the leg. What do? You just drop the square root of 2. So that's 8. This is 8. The whole side must be 16. And it's a square, so it's 16, 16, 16, and 16. So, what's S? S, a side, is 16. The apothem is, oh, in a 45-45, aren't these 2 legs the same? Mm-hmm. The apothem is 8. The perimeter is 16 times 4. That's going to be 64. And the area, 1/2 apothem times perimeter. That's 1/2 times 8 times perimeter is 64. That's going to be 4 times 64, 128, 256. 256. Hey, another way to do that, isn't it just going to be 16 times 16? Guess what 16 times 16 is? 256. Same thing. Isn't that cool? What do I have here? Triangles, same deal. Last thing I say before, man, I'm out of time here. For triangles, this will, if it's a regular triangle, an equilateral triangle, we know these angles are 60. So this has to be 60, which means this has to be 30. And if that's 30 and that's a right angle, this has to be 60. And knowing that, we can figure out everything. We can figure out everything we need. You're told the perimeter is 12 square root of 3. So each side must be 1/3 of that. Each side is 4 square root of 3. That means this piece is 2 square root of 3. And if that's 2 square root of 3, do you remember how to go from long leg to short leg? Drop the square root of 3. What's that make the radius? Short leg to hypotenuse, double it. 4. We now have everything we need to find the area, but we're out of time. So, your assignment? Yep, I've given you an assignment on this. It is, gotta hurry, because I think the bell's probably about to ring on me. Page 443, numbers 2 through 12 even. Jot that down quickly before we run out of time. And I will be back tomorrow. Sorry, maybe good or bad news, I don't know. But I will be back tomorrow, like it or not, and we'll go over page 443, numbers 2 through 12 even. And that's it. Hope you enjoyed the 2 videos. It's math, I know. How can you enjoy math? Oh, come on. But goodbye.
Goodbye.